Okay. All right, so on Monday we ended Unit 7. Today we are starting Unit 8. Okay, this is when we start graphing sine, cosine, all the trig functions. We're going to start learning how to graph those. Today's the introduction to graphing. So when we graph sine and cosine, okay, we have periods and we have amplitudes. So let's look at the first two boxes that are open, period and amplitude. On period, the definition of a period is the length of a cycle okay. Also, it can start at any point. Okay, an amplitude is half the distance between the minimum and maximum. Okay, and I will label those up here for you. Okay, so if you look at the graph at the top, a period, for example, would be for sine from here to here. This would be considered one period. Okay, your amplitude would be the distance between the whole period. So between the maximum and the minimum. This would be your amplitude. Okay, it's the same thing for cosine, except for cosine, your period is not 2 waves, it's just the 1. So that would be your period. And your amplitude would still be considered that distance right there. This is a little bit different than what you've seen before. Okay, they also both have functions. So if we have a sine function, for example, f of x equals sine of x, okay? The amplitude is the absolute value of a, which is just your number in front of sine. And your period would be 2 pi over the absolute value of b. B being the number in front of x. So a is the number in front of your sine or your cosine. B is the number in front of your x or your coefficient. Okay, so knowing that, on number 1, if we're given f of x equals sine 4 of x, your amplitude here is just understood to be 1, because there's not anything in front of sine. So our amplitude there would just be 1. Your period would be 2 pi over b. B here is 4, so we have 2 pi over 4. That can be reduced to 1 pi over 2 or just pi over 2. So that would be your period there. Okay, on number 2, we're given f of x equals 7 halves times your cosine of x. So our amplitude is what? Your 7 over your 2. And your period here, this time is understood to be 1 because there's not anything in front of x, right? So we would put 2 pi over 1, which essentially is the same thing as just saying 2 pi. Does that make sense? Okay, so just knowing that it's the absolute value of a or b. So if we were to have a negative, so like down here on number 3, our amplitude is technically -5, but since it's supposed to be the absolute value, our amplitude is just 5. And your cosine is 2 pi over 1/3. Okay, so 2 pi over 1/3 can be reduced.
The period or
the amplitude. Or, I'm sorry. I got myself confused. It's the period. You are right. It is the period. Okay, so 2 pi over 1/3 can be reduced to 6.
Wait, where did you get the 2? Oh, never mind.
The 2 pi is from the formula. Up top. Sorry, confused you right there for a second. I was getting ahead of myself. Okay, so that is for sine and cosine. So flip to the back and we're going to look at tangent. The graph of tangent looks a little bit different than sine and cosine. Okay, so if we're given f of x equals a tangent b of x, the period there would be pi over the absolute value of b. And the difference between sine, cosine, and tangents is tangents have several asymptotes. Okay, they are odd multiples of pi over 2 times your absolute value of b. Okay, they're all the odd multiples of 2 absolute value of b under pi. Okay, and I also want to label just so you can see on your graph here. So your period is actually just everything in between those lines. That's considered to be your period. And then instead of amplitudes, they just have asymptotes. So basically, everywhere those lines do not touch, you have several tiny little vertical asymptotes. Okay, again, this is just kind of an intro to graphing. So we'll learn more about the difference of the graphs moving on in the unit. Okay, so let's look at number 11. On number 11, okay, it wants us to find the period here. So if our period is pi over the absolute value of b, b being understood to be 1 right here. So we have pi over the absolute value of 1, which is the same thing as just saying pi. So pi is your period there. Okay. So basically, at every pi, you have a point. So here we have a point. 2 pi, we have a point. Negative pi, there's a point. And negative 2 pi, there's a point. Okay, and then your periods, or your asymptotes, I mean, are halfway between those. So we can technically have one at 0, 2. So your asymptotes would go halfway in between those points. So in between all of those. And you can actually graph this on Desmos too. It should show up the same way. Okay. That means we have a graph going up this way and down the other way. So your graph for this function looks something similar to this. So your lines will approach but never touch those asymptotes. Tangent graphs are very different. Okay. I think that's good for tangent notes. We'll do more of this tomorrow, especially since I have several people absent today. Okay, so on your practice page that I also passed out to you, all you have to do there is find your amplitude and your periods for each of those functions. And that's mostly just for practice. So y'all can work on that. It's not going to be due till tomorrow since we have so many people out for sports anyways. I'm going to post this in Teams also. So I'll post the finished notes, my teacher notes into our files like I usually do. And I'll put the assignment up in assignments on Teams for everybody so that you can see that. And then it won't be due till tomorrow.